Okay, we got another angular kinematics problem. We've got a 70 centimeter tire, and it goes from uniform rest to 20 meters per second in 14 seconds. So if you think about this, I've got an initial velocity of 0, a final velocity of 20 meters per second, and the time it took was 14 seconds. So what I want to do, it's asking for, I'm going to need to find the acceleration. So it's important to find the acceleration. So I'm going to use just kinematics equations. And I'm just going to say, if you recall, V2 equals V1 plus AT. V2 is 20. V1 is 0 plus A times 14. And I get the acceleration to be 1.42 meters per second squared. Now, what I'm trying to do is find how many times does the tire rotate. So what I want to do is I want to convert my acceleration in meters per second squared into angular acceleration. And angular acceleration is the symbol alpha, and that's measured in radians per second squared. So I've got to convert this to this. So what I'm going to do is I'm going to say 1.42 meters per second squared. And since it's a circle, right? And a circle has a distance around it of 2 pi r, right? I can say that there are 2 pi, and then the radius here is 0.35, half of 0.70. That's how much meters are in a circle, right? And that is per 1 revolution. And then if you realize, then there is 1 revolution is equal to 2 pi radians. Now you might notice here that the 2 pi's cancel. So I'm going to take 1.42 divided by 0.35, and I get 4.08 radians per second squared. Now maybe what I should have done when I was setting this up is ultimately it's asking how many times does it rotate. You're asking for what angle does it travel through, or theta. And if you think about this, there's the equation, the kinematics equation, angular kinematics equation, and we say theta 2 equals theta 1 plus angular velocity W1 times t plus 1/2 times the angular acceleration squared. So that's why I was calculating this, because I knew I needed to find this alpha. Now, since it starts at rest, all right, so that means the W1 is 0, and we're going to start this at a 0 theta, and we're really solving for this answer. So I'm going to just say theta 2 is equal to 1/2 times 4.08 times your time, 14 squared. Make sure you square it, super important. And I end up with 400 rads. Now it's asking for how many times does the tire rotate, or I like to say the number of revolutions. And so if I take, I'll put it over here, if I have 400 rads over 1, I can then say there are 2 pi radians in 1 revolution. And I just take 400 divided by 2 pi, and I get 64 revolutions.